Hello friends, Prerna this side from iNeuron. Welcome back to all of you. So we are here with a new topic, sum to n terms of special series. So in the previous video, we have discussed some questions on geometric progression, and now we are going to discuss sum to n terms of its special series. See, special series are neither AP nor GP. It is combination of AP and GP. Okay, so first of all, we have to discuss that how these question can be solved. The method of solving such type of question is little different from arithmetic progression and geometric progression. So before that, we need to understand that what are the formulas that we are going to use. So the very first thing is sum of first n natural number 1 plus 2 plus 3 plus n is actually n plus 1 by 2. Okay, so this is a direct formula of sum of natural numbers. Similarly, sum of square of the first n natural numbers is equal to n plus 1 to n plus 1 whole divided by 6. Similarly, for the third formula, we have sum of cubes of the first and natural numbers is equal to Sn is equal to n plus 1 whole square by 4. So this is the formula that we are going to apply in this exercise. See, special series have a different method of solving question. They will not follow a single particular formula like we do in APs and GPs. Okay, so let's discuss how we can solve such questions. Exercise 9.4 of NCERT. Okay, now find the sum to n terms of each of the series in exercise 1 to 7. So in this exercise, you will see that the pattern of question is quite different. The pattern is 1 into 2 plus 2 into 3 plus 3 into 4 plus 4 into 5, and it goes on like this, isn't it? So in this pattern, we can see if I'll solve this, it is neither an AP nor a GP, isn't it? Sorry. So it is 2, it is 6, it is 12. So it is nor a AP, neither a GP. So see, what we have to do here, we have to find the nth term of this series. Nth term of this series. So first of all, see that the first terms are 1, 2, 3 in each group. In each group, this is first group, this is second group, this is third group. Okay, so the first element is 1, 2, 3, 4, and it goes on like this. So this is actually natural numbers. So can we find the nth term of this series? Can we find? Yes. Nth term is, this is an AP, so it is A plus N minus 1D. So if I'll solve it, it is 1 plus N minus 1. So it is nothing but N. So I am writing n. Now what are the second term of each group? It is 2, 3, 4 like this, isn't it? 2, 3, 4, 5 like this. So again we have 2, 3, 4 like this. So if I'll find the nth term, so it is A plus N minus 1. D is 1. So it is 2 plus N minus 1. So it is N plus 1. So for the second term of each group, we have n plus 1. Got it? So this is nth term. Now the question says that you have to find sum to n terms. Sum to n terms. So how we can do this? First of all, our nth term is n square plus n. Our nth term is n square plus n, isn't it? Now, see, you have to write the equation in terms of k. So you have to replace n by k. So I am writing ak is equal to k square plus k. Now the next thing that we need to find the sum. So you have to put a summation where the value of k lies from 1 to n, and you have to put this sign on both sides. So we have summation k is equal to 1 to n k square plus k. That's it. Now see, this is summation k equal to 1 to n k square plus summation k equal to 1 to n k. Can we write it like this? Yes, we can write it like this. Now what we have to do is we have to put the formula. See what it says. This part is actually k square where value of k lies from 1 to n, which means it is actually, this is a rough work. You don't need to write it in the solution. So if I'll put the value of k 1, then it is 1 square. If I'll put the value of k 2, then it is 2 square, and it goes on like this. Similarly for the second part, if I'll put the value of k as 1 2 3 4 5, then it is 1 plus 2 plus 3 and goes on. So these are the two brackets. So this is 1 square, 2 square, 3 square, and this is 1 2 3 like this. Okay, so here we have the formula for sum of square of natural number. Sum of square of natural number is n plus 1 to n plus 1 by 6. So I'll write n plus 1 to n plus 1 by 6 plus, here it is 1 plus 2 plus 3, so it is sum of natural number, so it is n plus 1 by 2 by the first formula. Okay, now see, we can take common n plus 1. So I am taking n plus 1, and at the denominator we can take 2. So we are left with 2n plus 1 by 3 plus 1. Okay, now in the next step what we can do, n plus 1 by 2, and it is 2n plus 1 plus 3 by 3. So it is nothing but 2n plus 4, isn't it? So it is n plus 1 by 2, 2n plus 4. So if I'll take 2 common, it is n plus 2 only divided by 3. Cancel out. So it is n plus 1, n plus 2. So the answer is n plus 1, n plus 2 by 3. So this is the answer of question number 1. So this is the method of solving question of special series. First of all, you have to find the nth term. So I have taken the first term of each group and find out the nth term, and then again you have to see second term of each group and you have to find the nth term. Since both are in product, so nth term of both the element is multiplied. Okay, n and n plus 1, this is the nth term, convert it into k, and then you have to find the sum. So you have to put summation k is equal to 1 to n. So you have to put this in every question. Okay, there is no difference in another question. So the next question is question number 2. Let's discuss what it says. The question is 1 into 2 into 3, 2 into 3 into 4, 3 into 4 into 5. Now see, we have 1, 2 and 3. We have 1, 2 and 3 at first place. So for 1, 2, 3, we have nth term which we have already found out. So it is n only. Now we have 2, 3, 4. So it is 2, 3, 4. So nth term is again 2 for 2, 3, 4. We have n plus 1. So what I am writing here, n plus 1. And after that we have 3, 4, third element of each group, 3, 4, 5. So it is 3, 4, 5. So what will be the nth term? 3 plus n minus 1 d. So it is nothing but 3 plus n minus 1, n plus 2. That's it. N plus 2. So our nth term is product of each nth term. So it is n plus 1, n plus 2. Okay. Now what we can do here, we can multiply it. So it is n square plus n and n plus 2. So it is n cube plus n square plus 2n square plus 2n. So we have n cube plus 3n square plus 2n. What is the next step? We have to convert this in terms of k. So it is ak is equal to k cube plus 3k square plus 2k. And next step is we have to put the summation sign. So it is summation k to k 1 to n a k is equal to summation k equal to 1 to n k cube plus 3 into summation k equal to 1 to n k square, and then 2 summation k equal to 1 to n k. Now see what it says, k cube. So sum of cube of natural number, 1 cube plus 2 cube plus 3 cube, like that. So for that we have n plus 1 whole square by 4. So we will write n plus 1 whole square by 4, and then we have 3. So it is sum of square of natural number, 1 square plus 2 square plus 3 square. So it is n plus 1, 2n plus 1 by 6. Okay, n plus 1, 2n plus 1 by 6. So I have applied the same formula, and then we have 2 into summation k, that is 1 plus 2 plus 3. So sum of natural number, it is n plus 1 by 2. Okay, so this is the complete formula for each term. Now what we can do here, we can take common. First of all, we can cancel out these two, 3 2 times. Okay, so we can take n plus 1 since it is present in each group. So we have n plus 1 as common. Now see, n square was there, I have taken n, then we have n. Similarly, n plus 1 square was there, I have taken 1 time, then we are left with 1 time here and 4 at the denominator. Okay, in the next group what we have? In the next group we have n plus 1 taken common. We have 2n plus 1 by 2 plus, now n plus 1, so we have only 1. Okay, so after taking common we have this thing. Got it? Now in the next step we can take LCM, isn't it? So I am taking LCM. It is 4 at the denominator. It is n plus 1, okay, plus 2 into 2n plus 1, and then we have a 4. That's it. Got it? Now what we have to do is, it is n plus 1 by 4. n plus 1 by 4. Now what it will give? It will give n square plus n plus 4n plus 2 plus 4, that is 6. Okay, that is 6. Okay, now what we have to do? We have to factorize it, n plus 1 by 4 n square plus 5n plus 6. Okay, so it is n plus 1 by 4. Now if I'll factorize it, it will give n plus 2, n plus 3. Since it is 6, so we will write 3n plus 2n, so it will give like this. So this is the answer of question number 2. I hope this question is clear to all of you. Okay, so the answer is n plus 1, n plus 2, n plus 3 by 4. Okay. Moving on to next question. Now in this question what we see, we have 3 into 1 square, 5 into 2 square, 7 into 3 square, and so on. So we have 3, 5, 7. Okay, 3, 5, 7, and so on. So nth term is 3 plus n minus 1 d. So it is 3 plus 2n minus 2. So it is 2n plus 1. So we have 2n plus 1. Isn't it? 3, 5, 7. So it is a, that is 3 plus n minus 1, and d is 2. So it is 3 plus 2n minus 2. 3 minus 2 is 1. So we have 2n plus 1. And after that we have 1 square, 2 square, 3 square. So we can simply say it is square of natural number. Okay, so this is the nth term of given question. So if I'll solve it, it will give 2n cube plus n square. ठीक है? 2n cube plus n square. Okay, now we will write kth term. as we do always. So it is 2k cube plus k square. Okay, 2k cube plus k square. Now what we have to find? We have to find summation. So it is summation k is equal to 1 to n ak, and same thing on that side also, summation k is equal to 1 to n 2k cube plus summation k equal to 1 to n k square. Okay. Now in the next step what we are going to do, 2 and then summation k cube, again sum of cube of natural number. So it is n plus 1 whole square by 4, and here we have n plus 1 2n plus 1 by 6. That's it. Again, we can take common n plus 1, and from denominator we can take 2. So I am writing it, I am taking common. We have n plus 1 and at the denominator it is 2. So from the first group we can say that we are left with n plus 1 plus 2n plus 1 by 3. So it is n plus 1 by 2, and this is 3n square plus 3n plus 2n plus 1 by 3. So I have taken LCM. So now we have n plus 1, 2 into 3 is 6, and here we have 3n square plus 5n plus 1. Now we can not factorize it, since 3 into 1 is 3 only, it will not give 5 on adding, subtracting, anything. So we have the answer of question number 3. We have the answer of question number 3. Okay. Okay, so moving on to next question, that is question number 4. Question number 4 says, this question is quite different since the pattern of the question is different. The question is in fraction and all the numbers are at denominator. So we will solve this question in little different manner. Let's see what we are going to do. So it is 1 by 1 into 2 plus 1 by 2 into 3 plus 1 by 3 into 4, and it goes on like this. Okay, this is the question. Now see, we can write that the nth term is 1 by n plus 1. If you will go through the nth term, so 1, 2, 3 will give n, and 2, 3, 4 will give n plus 1, as we have discussed earlier. Now can we write this question like 1 by n minus 1 by n plus 1? Can we write it like this? Let's solve this question. If I'll write n plus 1 and I am taking LCM, so it is nothing but 1 by n plus 1. This is the question, isn't it? Okay, so we can write this in terms of this. Now if I want to find the terms, like if I want to find the first term and then second term and then third term, then what it will give? If I'll put the value of n as 1, it is 1 by 1 minus 1 by 1 plus 1, 2. This is first term. Now if I want to find the second term, it is 1 by 2 minus 1 by 2 plus 1, that is 3. Again I want to find the value of third term, so it is 1 by 3 minus 1 by 4. Okay, so this is the pattern. Now if I want to find the nth term, what is the nth term? 1 by n minus 1 by n plus 1. Okay, this is the question. Now see, if I want to add these things, then it is a1 plus a2 plus till an. Okay, a1 to an. Now see, minus 1 by 2 plus 1 by 2. See the pattern of cutting the terms diagonally like this. So minus 1 by 3 plus 1 by 3. So this will cancel out with something like this. Something like this. Okay, so what we have now, we have summation an ak or anything, so I am writing an only. So sum is summation k equal to 1 to n ak, that is a1 plus a2 plus a3 plus an, and it is 1 minus 1 by n plus 1. Okay, rest of the terms have been cancelled out. So it is n plus 1. So we have the answer n by n plus 1, and this is solution of question number 4. Okay. Okay. Next question. Next question is question number 5. Question number 5 says 5 square plus 6 square plus 7 square till 20 square. So first of all we have 5, 6, 7. So if I write the nth term of 5, 6, 7, so it is a plus n minus 1 d. So it is 5 plus n minus 1. So it is n plus 4. And it is square. So I am writing n plus 4 square is the nth term. Can we write it like this? If I'll put the value of n as 1, it is 1 plus 4, 5 square, 6 square and so on till 20. So this question is not in terms of n. The question says that you have to find the sum till 20 when the value of the last term is 20. So we'll discuss later. First of all, this is the nth term and this is a square plus, now ak is equal to k square plus 8k plus 16. Okay, what is the next step? We have to put a summation. So it is k equal to 1 to n ak is equal to summation k is equal to 1 to n k square plus 8 into summation k is equal to 1 to n k, and then we have 16 and it will be 16n at the end of the solution. So now we have k square and formula for this is n plus 1 2n plus 1 by 6. Similarly for this part we have 8 n plus 1 by 2 plus 16. 16n, I'm sorry, 16n. Okay, so we have n plus 1 to n plus. Now in this question what should be the value of n so that it will become 20 square? So n plus 4 should be 20, or we can say it should be like this for getting the last term. Okay, so simply n plus 4 is equal to 20, which means I have to put the value of n as 16. 20 minus 4, that is 16. So I am putting n is equal to 16. So it will give the last term. So it is, I'm solving it here. It is 16 plus 1 17. Okay, and then 16 into 2 32 plus 1 33 by 6. Okay, then we have n plus 1 and a 4 into 16 into 17 plus, then we have 16 into 16 into 16. So this is the, now see, now we have to solve it and it will give the answer. So it is 8 into 17 into 11 plus 4 into 16 into 17 plus 16 into 16. See, now what we can do here, we can take 8 common from all the groups. So we have 17 into 11. So it is 187 plus 4 and 16 are there. So 4 into 8 into 2, isn't it? So if I'll take 8, then we have 8. So it is 8 into 17 plus 32. Okay, plus 32. Now in the next step what we do, 8 into 187 plus 136 plus 32. Now solve this equation, it will give you the answer. So it is 2840. This is the answer. This is the answer. You can check the calculation. Now moving on to next. I hope this question is clear. This question is very easy. Just you have to find this term. So this value, the nth term should be 20 square. So we have n plus 4 whole square. What should be the value of n? Show that it will remain 20 square. So I have equated n plus 4 with 20 to get the value of n, and I have placed the value of n in the given solution. Okay. Now the next question is question number 6. Question number 6 is again another pattern. 3 into 8 plus 6 into 11 plus 9 into 14. That's it. Now the first terms are 3, 6, 9. Now what is 3, 6, 9? AP, GP, what it is? It is an AP, isn't it? So it is A plus n minus 1D. So it is 3 plus 3n minus 3. So it is 3n only. Okay, so nth term is 3n. And then 8, 11, 14. 8, 11, 14. So it is A plus n minus 1D. So it is 8 plus 3n minus 3. So it is 3n plus 5. So it is 3n plus 5. Okay. Now what is the nth term? Let us multiply this part. It is an is equal to 9n square plus 15n. So ak is 9k square plus 15k. Okay. Now summation k is equal to 1 to n, ak is equal to 9, summation k is equal to 1 to n, k square plus 15, summation k equal to 1 to n, k. Okay. Now it is 9 into, what is the formula for sum of square of natural number? It is n plus 1, 2n plus 1 by 6. And here we have 15 n plus 1 by 2. Okay. So we have 2 at the denominator and we can take 3 from this and from this. So I am writing 3 by 2 as common, n plus 1. So in the first group we have 2n plus 1. And in the second group we have 5. So it is 3n plus 1 by 2, and here we have 2n plus 6. So 2n plus 3. I am taking 2 as common. So it is nothing but 3n plus 1, n plus 3. Got it? Okay. So this is the answer of question number 6. Easy. So moving on to next question. Next question is question number 7. Question number 7 is quite different. Question says it is 1 square plus 1 square plus 2 square plus 1 square plus 2 square plus 3 square, and it goes on like this. So see, what will be the last term? This is the first, this is the second, this is the third. So last will be 1 square plus 2 square plus 3 square till n square. It should be the nth term, isn't it? So what is nth term for us? It is 1 square plus 2 square something. So what is the formula of this thing? We know that square of sum of natural number, square of sum of natural number is n plus 1, 2n plus 1 by 6. Isn't it? So what is the nth term we have? N square plus n, 2n plus 1 by 6. So it is 1 by 6, 2n cube plus n square plus 2n square plus n. So it is 1 by 6, 2n cube plus 3n square plus n. So this is our nth term of given series. Now what we have to do? We have to find the sum. So I am writing it in terms of k. Okay. Okay, and now I am putting the summation sign in the given solution. So it is summation k equal to 1 to n ak is equal to we have 1 by 6, so leave it outside the bracket. Now we have 2 into summation k equal to 1 to n k cube plus 3 into summation k equal to 1 to n k square plus summation k equal to 1 to n k. Okay, now it is 1 by 6 2. Now what is the sum of cube of natural number? So we have n plus 1 square by 4. Okay, then we have plus 3, it is n plus 1 2n plus 1 by 6, and then we have n plus 1 by 2. Got it? Okay, so what it will give? It will give 1 by 6. See, here we have n square n plus 1 square by 2 plus n plus 1 2n plus 1 by 2, and again we have n plus 1 by 2. Okay, now what we can do? We can take common n plus 1 and we can take 2 from the denominator. So we have 6 into 2 at the denominator. So we have n plus 1 plus 2n plus 1 plus 1. Okay, so what we have here? n plus 1 by 12. And this part will give n square plus n plus 2n plus 1 plus 1 2. Okay, so in the next part we have n plus 1 by 12, and here we have n square plus 3n plus 2. Okay, so it will give n plus 1 by 12. Now see, we have n square plus 3n plus 2. So if we will factorize it, it will give n plus 1, n plus 2. Isn't it? So we can write n by 12, n plus 1 square, n plus 2. So this is the answer. Okay, got it? Okay, so moving on to question number 8. So we have two questions in this slide. Find the sum to n terms of the series in exercise 8 to 10 whose nth term is given by. See, in these type of question, you don't need to find the nth term since nth term is already given, isn't it? So what we are going to do, we just solve it. So nth term is n plus 1, n plus 4. Let's solve it. It will give n square plus n, and then we have n plus 4. So nth term is nothing but n cube plus n square plus 4n square plus 4n. So it is n cube plus 5n square plus 4n. This is nth term. Now what will be the kth term? Kth term is k cube plus 5k square plus 4k. Okay, now we have summation k is equal to 1 to n ak is equal to summation k is equal to 1 to n k cube plus summation k is equal to 1 to n k square with a 5, and then we have 4 summation k equal to 1 to n k. Okay, so we have n plus 1 whole square by 4 for k cube, and then we have 5. Okay, then we have 5, and it is n plus 1 to n plus 1 by 6, and then we have 4 n plus 1 by 2. Okay, sum of natural number, sum of square of natural number, sum of cube of natural number. Now from these three groups we can take 2 at the denominator, 2 at the denominator and n plus 1 at the numerator, isn't it? So now we have n plus 1 by 2. Okay, then we have 5 by 3 n, 2n plus 1, isn't it? Since we have taken n plus 1, so we have 5, 2n plus 1 and the 3 and then we have 2. Okay, now on solving it further, it will give you the answer. So let's solve it. So in the next step what we have, n plus 1 by 2 and here we have 6. Okay, 6, so it is 3n plus 1 plus 10 2n plus 1 and then we have 18. Okay, so it is n plus 1 by 2 into 6 is 12 and then we have 3n square plus 3n plus 20n plus 10 plus 18 plus 18. Okay, so now we have 10 plus 18. Since we have taken 2 common here, so we cannot write 2 here. We have to write 4 here, isn't it? So there is a issue. Wait. So in the next question it says find the sum to n terms of the series in exercise 8 to 10 whose nth term is given by. So in this question nth term is given, so you don't need to find the nth term by seeing any series. It's directly an, which is n plus 1, which is an equal to n plus 1 n plus 4. Okay, so simply we need to simplify it. It is n square plus n plus 4 and then it is n cube plus n square plus 4n square plus 4n. So it is nothing but n cube plus 5n square plus 4n and this is nth term. Now if I want to find the kth term, it is k cube plus 5k square plus 4k. Okay, so now we need to find the sum. Summation k is equal to 1 to n ak is equal to summation k equal to 1 to n k cube plus 5 summation k equal to 1 to n k square plus 4 summation k is equal to 1 to n k. Got it? So in this question nth term was already given. I have just simplified it. Okay, replace n with k and put the summation sign on each term. Now what is the formula for sum of cube of natural number? It is n square n plus 1 whole square by 4. Okay, what is the formula for sum of square of natural number? It is n plus 1 2n plus 1 by 6. And then we have 4. Sum of natural number is n plus 1 by 2. Okay, now from these three groups we can take common. So I am taking common. I am taking common n plus 1. Out of 4, 6, 2, I am taking 2. So in the first group we have n plus 1, okay, by 2. Then we have 5, 2n plus 1 by 3. And then we have taken 2 from the denominator, so we have 4 only. Okay, since we have taken n plus 1 by 2. So now we have n plus 1 by 2. Okay, on taking LCM, it will give 3n plus 1, 10, 2n plus 1, and then we have 24. Okay, so it is n plus 1, 2 into 6 is 12, 2 into 6 is 12, and here we have 3n square plus 3n plus 20n plus 10 plus 24. So it is nothing but n plus 1 by 12, and then we have 3n square plus 23n. It is 10 only, so it is 10 only. So we have plus 34. So this is the answer. This is the answer of question number 8. For question number 9, we have n square plus 2 to the power n. Okay, so we will discuss in next slide. This is question number 8. I hope it is clear to all of you. So the question number 9 is n square plus 2n. Nth term is nothing but n square plus 2 to the power n. So kth term is k square plus 2 to the power k. Okay, on putting summation, k equal to 1 to n, ak is equal to summation k equal to 1 to n k square plus 2k. I'm not putting, sorry, it is in power. I'm sorry, it is in power. So it is summation k is equal to 1 to n 2 to the power k. So let's discuss. So sum of square of natural number, we know that it is n plus 1, 2n plus 1 by 6. Okay, now we have 2 to the power k, and the value of k varies from 1 to n. So we can say it is 2 to the power 1 plus 2 plus 3 plus n. Okay, if I'll put the value of k, then it is n. See, so we have at the power of 2, we have an AP. Okay, so we have to put the value of sum of n terms of AP. So it is n by 2, 2 into 1, 2a plus n minus 1 d, that is 1 again. So we have n plus 1, 2n plus 1 by 6, and here we have 2 to the power n by 2, and it is n plus 1. N by 2 into n plus 1. Okay, that's it. You can leave this here only, and we will discuss next question, question number 10. Question number 10. Okay, so in question number 8, find the sum to n terms of the series in exercise 8 to 10 whose nth term is given by. So 8, 9 and 10. Question number 8, 9 and 10 have nth term. You just need to find the sum. So let's start from question number 8. Question number 8 says nth term. Nth term is n plus 1, n plus 4. So nth term is n plus 1, n plus 4. So if I'll solve it, it is n square plus n, and here we have n plus 4. On multiplying it, it will give an is equal to n cube plus n square plus 4n square plus 4n. So simply it is n cube plus 5n square plus 4n. Okay, now if I'll put the value of n as k, here it is n only, so it is ak is equal to k cube plus 5k square plus 4k. After that we have to put the summation sign, so it is k equal to 1 to n ak equal to summation k equal to 1 to n k cube plus 5 summation k equal to 1 to n k square plus 4 summation k equal to 1 to n k. Now see, what is the formula for this? Sum of cube of natural number is n square n plus 1 whole square by 4, and then we have n plus 1 2n plus 1 by 6, and then we have 4 into n plus 1 by 2. Okay, now what we can do, we can take common. So what we can do, we can take 2 from the denominator and n plus 1 from numerator. So we have n plus 1 by 2 plus 5 2n plus 1 by 3, and then we have 4. That's it. That's it. Okay, so we will solve it further. What it will give, I'm solving it here. So it is n plus 1 by 2. Okay, now if I'll take LCM, it is 6 at the denominator, and we have 3 into this, so it is 3n square plus 3n square plus 3n, and then we have 10 into 2n plus 1. Okay, and then we have 24. Okay, this is second bracket. Now on moving further, it is n plus 1 by 12, and this will give 3n square plus 10 2s are 20n plus 3n 23n plus 10 into 1 10 plus 24 34. So this is the answer of question number 8. Question number 8. Now the next question is question number 9, which I am going to discuss in next slide. So it is n square plus 2 to the power n. This is the nth term. Okay, what should be the kth term? Kth term is k square plus 2 to the power k. If I'll put the summation, it is k 1 to n ak is equal to summation k equal to 1 to n k square plus summation k equal to 1 to n 2 to the power k. Now if I'll put the value of k, then it is sum of square of natural number. So what it should be? It should be n plus 1 2n plus 1 by 6. And here if I'll put the value of k, then it will be like 2 to the power 1 into plus 2 to the power 2, like this. So this is nothing but a GP. Okay, so sum of n terms of a GP is given by a, what is r? 2 square by 2 is 2. So r n minus 1 by r minus 1, and a is, first term is nothing but 2. So it is n plus 1 2n plus 1. This is question number 9. Okay, so we have 2 into 2 to the power n minus 1. We cannot proceed further, and we don't need to proceed further. That's it. So this is the answer of question number 9. Now this is the last question of this exercise 9.4, question number 10, and again we have to find the sum. So nth term is 2n minus 1 whole square, which means it is a square plus b square minus 2ab, that is 4n. So kth term is 4k square minus 4k plus 1. Now if I'll put the summation k is equal to 1 to n, ak is equal to 4, summation k equal to 1 to n k square minus 4 summation k equal to 1 to n k, and then we have n on putting the summation. So it is 4 n plus 1 2n plus 1 by 6, and then we have 4 n plus 1 by 2 plus n. Okay, now we can take n common, so we have 2 by 3 n plus 1 2n plus 1 minus, I have taken n only, so we have 2n plus 1 plus 1. That's it. Now on proceeding further, we can solve this. Okay, we can simplify this. So it will be n by 3. If I'll take LCM, it is n by 3. And here it is 2. 1 second. Two n square plus minus 2n minus 2. Sorry, it should be 6, no? 6. Is it correct? Okay, on proceeding further, we can simplify this and it will give you the answer. This is very easy, we don't need to discuss it. So that's it. So exercise 9.4 is completed. So we have gone through many questions, 10 questions, and all questions are of similar pattern. Okay, you just need to focus on the pattern of the question. It will give you the hint of the solution. And the question number 4 was different. All question of such type you have to solve in this manner only. Okay, so we will meet in the next video, and in next video we are going to discuss miscellaneous exercise of chapter 9 of NCERT book. Okay, so that's it for the video. Till then, bye bye.